Greetings, my name is Angel Escobar, and today I'll be presenting on the Mars Pathfinder spacecraft and its payload, the Sojourner Rover. The Mars Pathfinder's launch vehicle was a Delta II 7925 and was launched from the Cape Canaveral Air Station in Florida on December 4th in 1996. The spacecraft utilized an airbag landing system and successfully landed on Mars on Independence Day in 1997, and the final data transmission that was successfully received was on September 27th, 1997. Some characteristics about Mars are as follows. As you can see, Mars is 1.5 times further from the Sun than the Earth is. So Earth is about 1 astronomical unit away from the Sun, while Mars is 1.5 astronomical units from the Sun. The diameter of Mars is half that of Earth, so about 6,780 kilometers. A Martian day is known as a sol and is equal to about 24 hours and 37 minutes. A one-way radio signal traveling between Earth and Mars can take as little as 2.5 minutes to as much as 20 minutes. Its gravity is 38% that of Earth's, meaning that Mars' gravity constant would be equal to about 3.72 meters per second squared. The atmosphere on Mars is made up of 95.3% carbon dioxide, 2.7% nitrogen, 1.6% argon, as well as traces of oxygen, carbon monoxide, and water vapor. A few goals and requirements for the Mars Pathfinder mission were to design a low-cost alternative method that would deliver scientific instruments to Mars that would be used to explore Mars and conduct tests on soil and rocks, as well as to use the new technology to provide engineering data to us back on Earth. The spacecraft was formally named Carl Sagan Memorial Station in memory of the late astronomer. It initially weighed 894 kilograms and was about 1.5 meters tall, with a diameter of 2.65 meters. It included 2.5 square meter gallium arsenide solar cells, which provided electrical power, and when it had entered the Martian atmosphere, it weighed 584 kilograms. It later utilized the airbag method to land, and once the airbag deflated, the spacecraft weighed 370 kilograms. Once deflated, it revealed the pyramid lander that was 0.9 meters tall, with 3 triangular petals. Each petal had an area of 2.8 square meters and were able to supply 1,200 watt-hours of power. When unfolded, the lander measured to about 2.75 meters across, with the camera being about 1.5 meters above the ground. Also, the spacecraft is all controlled by a radiation-hardened IBM RAD6000 computer. Now let's talk about the spacecraft's payload. The Sojourner Rover is named after the African-American crusader from the U.S. Civil War era named Sojourner Truth. It weighed about 10.6 kilograms, plus an extra 5 kilograms of mounting and deployment equipment. Once deployed, its dimensions were 65 centimeters long, 48 centimeters wide, and 30 centimeters tall. For comparison, when it was folded in the stowage space, it measured 18 centimeters tall. It had a maximum travel velocity of 1 centimeter per second. It contained 6 wheels with a diameter measurement of 13 centimeters. It was powered by a quarter square meter solar array on its top surface, which was used to power 2 cameras and an alpha proton X-ray spectrometer, or APXS for short. It was able to send communications to Earth through its lander. The control system was built around the Intel 80C85, which had a computing speed of 100,000 instructions per second and 500 kilobytes of random access memory mass storage. Some scientific findings were a presence of rounded pebbles and cobble with sockets and pebbles in some rocks, which indicated signs of running water, possibly from a warmer past in which liquid was stable on the planet. Radio tracking provided a precise measure of the land that suggested that the radius of Mars is between 1,300 to about 2,000 kilometers. Another scientific finding was successful because of a magnet on the rover, which found airborne dust to be magnetic, possibly being maghamite. Dust devils were frequently measured by the scientific instruments on the lander and rover, attaining data with temperature, wind, and pressure sensors. It was also found that the lower atmosphere experienced water ice clouds, and there are abrupt temperature fluctuations recorded in the mornings. Here are some findings from the alpha proton X-ray spectrometer. Figure 1A features an X-ray spectrum of a rock known as A3 and nicknamed Barnacle Bill, which was measured on Sol 3 for a period of 13,780 seconds at nighttime. The argon peak in the spectrum is from the 1.6% argon found in the Martian atmosphere, and was found to be more pronounced when the alpha proton X-ray spectrometer sensor was not in immediate contact with the sample. The energy resolution of the X-ray detecting system was 254 electron volts at the 6.4 electron volt iron line. Figure 1b shows the X-ray spectrum from A15, which contained a sample of dark soil from the Mermaid Dune site acquired at nighttime on Sol 28 for a period of 10,510 seconds. The analyses in Table 1 expressed as oxides were normalized to 98% due to uncertainties in the measurement geometry, and the data for phosphorus, chromium, and manganese had large errors, so they were not included in the analyses. Uncertainties in the first table were derived from the range in differences found between certified and measured values for 8 reference standards. The column titled Org Sum is the original sums of the oxides before normalization. Some interesting names of the soil and rocks sampled are A8, also known as Scooby-Doo, A3, Barnacle Bill, and A7, Yogi. Table 2 features compositional data in the weight percent of a Martian meteorite named Zagami and the C2 chondrites Murchison performed by the Alpha Proton X-ray Spectrometer and Max Planck Institut für Chemie. Figure 2 on the left is a table that compares the chemical composition of 5 measured Pathfinder soils, A2, A4, A5, A10, and A15, normalized to a silica content of 44% by weight. The box that represents the Viking data reflects the range of the individual element concentrations, which were normalized to a silica content of 44% after being recalculated to 100% by weight. The figure found that Pathfinder soils were generally lower in sulfur and higher in titanium. The chlorine values are subject to uncertainties for both sites, but agree within their error bounds. From data from images and alpha proton X-ray spectrometers sulfur data, rocks are covered to a varying degree with adhering dust or a weathering rind similar to the composition of dust. The data denoted in Figure 3 are linear regression lines for silicon, titanium, magnesium, and aluminum versus sulfur of Pathfinder rocks, which are denoted with the filled circles. The linear correlation coefficient for silicon was 0.76. For titanium, it is 0.85, magnesium is 0.88, and aluminum is 0.38. The open circles on the graph are soils which were not included in the regression, but plotted it proves that the 0s values represent a soil-free rock composition too. Figure 4 shows a magnesium per silicon versus aluminum per silicon diagram of Martian meteorites marked with the filled triangles, the mean values of the soils from the Viking mission marked with open diamonds. Pathfinder soils were labeled as MPF soils, and A3 Barnacle Bill and calculated soil-free rock composition were marked with filled diamonds in comparison with terrestrial samples. Figure 5 is a histogram of some element concentrations in A3 Barnacle Bill, which is the hatched bar. A5 Pathfinder soil are also called dark next to Yogi, denoted with the filled bar, and Martian meteorites, denoted as the open bar. For magnesium, potassium, and iron, the Martian soil could be interpreted as a mixture of rocks and a more mafic component represented by the Martian meteorites. All of the data shown in the figure is normalized to silicon dioxide content of Barnacle Bill, which is 58.4% by weight. Some mission accomplishments from the Mars Pathfinder mission were as follows. The soil chemistry found on the mission was similar to that of the soil found in the Viking 1 and 2 missions, which suggests that the soil is a globally deposited unit. This was also the first mission completed in NASA's Discovery program of low-cost, rapidly developed planetary missions. The mission was also the first time an airbag landing was utilized, and it succeeded. Pathfinder relayed 2.3 gigabits of data, and the mission was meant to last only about a week with the battery it was using, but instead it lasted 83 sols, which is about 12 weeks, surpassing its initial perceived lifetime. That concludes my presentation on the Mars Pathfinder mission and the Sojourner Rover. This is a bibliography of the resources I used. I utilized data from NASA as well as the NASA Space Science Data Coordinated Archive and Science Mag. If you have any questions, comments, or concerns regarding this presentation or any of the subjects covered during it, feel free to contact me by email at angel.escobar@student.csulb.edu. Thank you.